Thank you, sir. Required to provide the term up there. Max. All right, in the opening, let's look at what we came up with. So in question 1, if n equals 5, how many electrons are there? Okay, how do you get that? What are the ways we can do that? Okay, I got 2n squared and I got add up the electrons in the orbitals, or you could have said sublevels. So if we use 2n squared, 5 squared is 25 times 2 is 50. That's the short way. Or you can add up the sublevels with the orbitals. So if n equals 5, how many sublevels are there? 5. So 5 sublevels would be 5s, 5p, 5d, and 5f, and 5 somebody. Okay? So how many orbitals are there?
1, 3, 5, and 7.
So how many electrons?
2, 3, 6, 7, 14, 18.
So you'd add all of these together and you would wind up with 50 that way. That's the other way to do it. All right, number 2. If L equals 3, what does N have to be as a minimum?
4.
4. Okay, so if L equals 3, what sublevel is it?
D.
Not D.
Oh.
It's F. Okay, if L equals 3, all right, that's an F sublevel. Okay, so to have F, S, P, D, F. Okay, so to have 4 sublevels, what does N have to be? N has to be a 4 to have 4 sublevels. Okay, you can't have an F sublevel unless you have N equals 4. Does that make sense? Yes, no? Okay, you have to know that L equals 3 is talking about an F sublevel. If you don't know that's F, you're sunk. Okay? You have to know that, I'll get rid of this. Try that again. that L equals 0 is what sublevel? L equals 1 is P, L equals 2 is D, and L equals 3 is F. Okay? You got to know that. So in order to have an S, N has to be what to have a S sublevel? 1, because one energy level gives you how many sublevels? 1. That'll be an S. So in order to have a P, N equals 2, because you can have how many sublevels at 2? 2. S and P. So if N equals 3, you can have how many sublevels? 3. What are their names? S, P, and D. So if N equals 4, you can have how many sublevels? What are their names? S, P, D, and F. So if I have L equals 3, what sublevel is that? That's F. So in order to have an F, you have to have what energy level to have a 4th sublevel? S, P, D, F, you have to have 4. Okay? Today's show.
Would you ever have one that's like L equals 4?
I could, and you'd have to have a what? L equals 4, you'd have to have a what? Yeah, well, it would be a 5th sublevel, so you'd have to have a what? N would have to be what?
5.
All right, if you have an S sublevel, what are the M values?
0.
Yep, because you have to know the L value. What number is assigned to S? Okay, L is 0. So to find M, M is minus 0 to positive 0. And we all know from math class, there is no such thing as minus 0 to positive 0. It's just what?
0.
It's just 0. All right. So now in 4, we're going backwards. We have minus 2 to positive 2. So that tells us the L is what if we're going from minus 2 to positive 2?
3.
Hold on, you're further along. I'm just doing the L. All right. So L would be what? What's this? What's this? So L is 2. So N has to be what?
3.
N has to be 3. All right. So if L is 2, what sublevel are we talking about? S, P, or D? That's a D. So in order to have a D, what does N have to be? S, P, D would be what? That's how they got 3. All right. How many electrons are there in just a px orbital? It's 2. Okay. Most people look at it and go 6 because they think P. But I'm asking about px. Okay. So px, py, pz. This has 2 electrons. This has 2 electrons. This has 2 electrons. So all of P has 6. But I'm asking about just px. So px can have how many? Can have 2. All right. How many electrons can N equals 2 hold? Yep. That's just like question 1. You can do 2n squared, or you can add up the sublevels. And what's the shape of the D sublevel? You can say 4 loop. Yep.
Oh, 6.
6, 8. Today's.
So you can use 2n squared on either.
What does it say? N equals, and you want the electrons? Yes. Yes.
What is the shape of F?
What's the shape of F? Flower. Flower. It's getting a little clearer. All right, what else? We'll talk homework? Yes, no? Okay. All right, let's do the chart first. And then we'll talk questions. All right, where's the chart? Here, Owen. All right, so we did n equals 2 yesterday, so we need to fill in the rest. So n equals 1 has how many sublevels? Its name, its value, number of orbitals, its electrons, its m value, its spin, and its total electrons, and its number of orbitals. Very good. All right, n equals 2 we did. So n equals 3. I wish I could make that bigger. All right. Its number of sublevels was 3s, so 3p and 3d. All right, its value.
1, 0, 1, 2.
Yep. All right, the number of orbitals in s.
1, 2.
Okay. Now, let's see if I can. There. Makes that a little easier. All right, the number of electrons in s.
2.
And in p.
6.
And in d.
10.
Okay. All right, so the m values is where I'm going to struggle to get this in here. All right, s.
0.
And in p.
-1, 0, 1.
And d. All right, spin. And the number of electrons in the energy level. And the number of orbitals. All right, questions about anything on that row? Anybody? All right, so n equals 4. How many sublevels? All right, their names. All right, so the value for S, for P, for D, and for F. Now, notice it didn't matter that I put a 3 or a 4 in front of them. Did their values change? Did their number of orbitals change? No. Did their number of electrons in the orbitals change? No. All right, the m values, did they change? All right, how many electrons in the energy level?
30.
And how many orbitals?
6.
Questions? Now, we said that you could use the formula 2n squared here. Is there a formula for the number of orbitals? What? Yes. Take the 2 off. It's n squared. Good, isn't it? What's what? This is for the number of orbitals. If you want to know the number of orbitals in the energy level, you just take off the 2. Because the electrons are just times 2 to get the electrons. So you just drop off the 2 to get the number of orbitals. It's just a shorthand way to do it. If you want it, you don't have to use it. You can just add up what we've been doing. All right, questions? Got anything on that before we run through the homework answers? Yes? No? All right, let's run through the homework answers. All right, number 1.
1.
Everybody got it? So I don't have to go back and repeat half of this. Yes, no? All right, what's the L value of the P sublevel? 1. How many orbitals are there in the D sublevel? 5. How many electrons are in the px orbital? 2. How many electrons are in the D sublevel? 10. N equals 3. How many sublevels do you have? 3. What are the names of the p orbitals? Px, py, and pz.
Oh, so how do you tell what they're asking?
I'd say shape if I wanted to know dumbbell or something of that nature. Okay? The names are px, py, and pz.
And is peanut dumbbell too low, like the individual ones, or?
They're just different ways to say the same thing. Depends on the text. I would take any of those for shape. You would not need to name all three. If I said on the quiz today, what's the shape of the P sublevel, and you wrote peanut, and Caroline wrote dumbbell, and Annette wrote 2 loads, I'd take any of the answers. All right, what's the L value of the S sublevel? If L equals 2, what are the M values? Yep, if L equals 2, what must N be?
3.
You all figured out a pattern for L and N yet?
Is it one number like N?
If L plus 1.
It's like one up.
It's one up, and there's one more than L. Okay? How many? Just asking. Y'all smart. Figured y'all get it. How many orbitals are there? N equals 2.
4.
4. Okay? How many electrons are there if N equals 4?
32.
32. What are the 4? Name the 4 quantum numbers. Okay? How many orbitals are there if N equals 3? 9. What's the value of L for the D sublevel? 2. 0, 1, 2. All right, you just got to remember, S starts at 0 because I'm doing them in order. Which sublevel has a value of 1? What's the N value if L equals 3? 4. Name the 4 sublevels. How many electrons are allowed if N equals 5? What are the M values of the P sublevel? Yep, -1, 0, and 1. What are the M values of F?
-3, -2, 1, 0, 1, 2, 3.
Yes, that went from -3 to +3 for those of you who didn't hear Chris mumble over there.
Sorry.
All right, what are the values for the spin quantum number? Positive and -1/2. How many electrons are allowed in the F sublevel?
32.
All right, in the F sublevel,
14.
14. Okay, 32 would be the entire N equals 4. All right, the F sublevel is just 14. All right, if M equals -2 or +2, what is N equal to? 3, because L would be 2, and N would be 1 more, so it would be 3. Fractions. Yes, ma'am. Number 12. Name the 4 quantum numbers. Principal, orbital, magnetic, spin. Anything else? Anybody need to go over something, explain before you do the figures? Yes, no? Thank you. Sure, are you getting clear? All right. First one, energy level and size.
And then orbital tells the orbitals.
No, orbital tells sublevel and shape. Orbital is, the number of orbitals is magnetic.
Oh, okay, so.
I can't fix them, stupid.
Wait.
Orbital actually has a different name. It's called azimuthal.
So the first one is.
Alright, grab your laptop. No. Really? Because I said. Nope. Grab your laptop.
So the principle is just N equals.
Principal is just N equals, yes.
Okay.
Walk all the way over there to get that.
Yes, you have to walk all the way over there.
Have app on my
Yes, you have Google on your phone. I'm aware. You have Safari. You have lots of technology in your hands. And I have an entire laptop cart full of laptops. Go grab one.
What if I was walking over there?
Positive negative one half,
Yep.
and then magnetic is N1, so it's
Yeah, no.
negative N to positive N, and then orbital is. You said it's not orbitals, so I don't.
Sublevel change. Only the L. Magnetic is the M.
It got me really
Okay.
Hey, Christy.
Are you too?
Yes. That is no excuse. People need to count. Reach. I like that one better.
You put in your real name, not something stupid. And don't put in my name. The last person who put in my name and played lost.
Yeah, my dad.
Made you feel bad.
Let me go out today. Alright, missing one. I have 18. No, I counted 18 people. There we go. Now we got 18. Alright, there's only 10 questions. No, we're only doing one. And I think I have all of these set at 30 seconds.
That is hard.
I don't have them set at a lot of times. No. You don't get anything other than the chance to review before your quiz. Alright, so if n equals 2, how do you do it since 6 people got it wrong?
It's SP, so then it'll be 1. So then it'll be 2.
2 plus.
4 times 2 is 8. And so there you go.
Alright, 2 plus 6 is 8, or 2n squared, which is 8. Alright.
Yeah, we don't get any.
Which quantum number tells size? Dang. Alright, which quantum number tells size? Alright, principal tells size. Sheesh.
Which is larger? Oh, God.
Are you okay?
That's better. Which tells size? The number or the sublevel? What tells size? The number or the sublevel? The number. So the 6 told you it was bigger.
Maybe I will say I look like.
The number's up there in black on the board.
Why is this so dusty?
I don't know. Use it fairly regularly in third and fourth, so I don't know why it's dusty.
It's like, what is dusty more than it's
Okay,
like.
can you explain to me why that's right? I got it right.
Alright, which sublevel cannot exist? If you have a second energy level, you're allowed how many sublevels? 2. What are their names? 2S and 2B. You can't have a 2D.
Wait, no. That is.
Alright?
I understand what I'm like.
Now 8S, technically 8S can have how many sublevels? 8. 8S would be the first of the 8. So 8S can exist. One day we may teach about 8S. We don't have any periods up there that are 8 at the moment, but we may one day. If you're in the 7th energy level, the 8th would be your excited state. So that can exist.
That just confused me all the way.
It's the L value of the S sublevel. Very good.
Dang, you answered quick. Jesus. Oh, no, no.
Fireman squad.
All right. Remember, N is what?
Still have 7.
1 more than L, or L equals 3. What sublevel are we talking about? F. So if it's an F, S, P, D, F, you have to have 4. Really?
Maybe. No. Okay, no, I did.
How many electrons are allowed in an orbital? 2. That's going to be important today when we get down there at number 4 on our agenda.
Oh, wow.
If M equals -1 to +1, what's L? If you're going from -1 to +1, what's L? L is 1. Okay? So if L is 1, that means N has to be 1 more than that, which is what? 2. Okay? So you could have also looked at it as 1, 2, 3. How many orbitals do you have? You got 3 orbitals, which makes you a P sublevel. All right, P sublevel means you have to have 1, 2 energy levels, which would still make you a 2. The shape of F.
Did you make this? Did you make this?
Yeah, I don't usually use the ones I search for. I usually make mine.
Yes.
All right. Peanut is which one? The 2 people who picked Peanut. Peanut is P. All right, last question.
Wait. Oh. Okay. Oh, I got it wrong.
All right. The 2 people who picked blue picked the what? Picked the orbitals. And the 5 people who picked the green picked the electrons and the what? F. Okay?
80 points. I don't like.
I was on top of the whole game.
Learning English.
You got speed on the last question.
Awesome.
Alright, if you will, put your laptops up. And then all you need is a pencil or a pen. You don't need a calculator, and you don't need a blue chart.
Okay, so principal tells shape. What do the other things say?
Huh?
Principal tells shape.
No.
It doesn't tell
Orbital
shape.
tells shaping.
What's the shape? What's the
Size and ear flow.
I made it. I'm here. I got to have something.
Can we see our
That's
other
how
Can we see our other quizzes?
No, because I can't put them in Power School.
This wall.
Power School's down.
This right?
Huh?
You can use this right?
No!
But that's.
I told you, you need a pencil.
Oh, maybe you forgot to mention that.
Y'all better be careful around the shower.
Come on, that's I can't reach them. Well, put down the one you can take.
I hope so.
I have to make an honest
Well, Karen told us that one time she ate cereal with water. I was like, ooh. Karen was like, I didn't know. I thought it would taste the same. She ate her cereal with water. Oh yes. Karen asked you know Karen. Yeah, she put water in her cereal.
What?
Because they didn't have milk. And I guess she just was like, this the job, talk that's the matter.
You just need to draw some noodles, drink water.
Sorry, this is.
Oh, Saturdays.
Alright, this is super quick. When you're done, just flip it upside down. Some of y'all are gonna be done on this side before I get to that side.
I closed my eyes.
Oh, yeah.
Saved by the. That's all I want to say.
Oh, wow.
I know this one. You write the answer down.
Oh, my God. I don't.
Good, write it down. And you don't get very long, so write your answers down. Quickly.
I need time to think.
You're not getting a lot. Think fast.
Is orientation in the same as pictures?
I don't remember, no. Is that for what? Not as a shape. Yeah.
What about Robinson?
Huh?
For real? What about Robinson?
No. You gotta write the word.
Is that supposed to be in space sometimes?
Huh?
Is it supposed to be in space?
Yes. All right, got another minute and then we're gonna take them up.
Do we have to name the sublevels on 8?
Nope. Lewis is not here. Angel is tardy. Is tardy. Karina is not here. That should be everybody. All right, pass Rose to the front. And your time from yesterday, right? But I can't get them back because I can't put them in power. It's a lot like finishing grades at the moment. After school is in standstill mode because power school is sort of down for us at the moment, and we can't finish posting grades for some odd reason.
I don't think mine will lunch.
Can you what?
I came out good in my lunch.
Yeah. You got third lunch? Yeah.
No, that's it.
No. I'm sure I've been here during the middle of my class. All right. So until we get an email from this class that says we can put grades in, even though these will be graded, I can't put them in PowerSchool. All right. Find your notes. We're going to talk about orbital notation today. You're going to need your periodic tables, and that's it. So locate those two. We're going to learn how to draw orbital notations and electron configurations. So we're going to add some, why did we do all this crap to periodic table today? All right, everybody got what they need? So I don't leave you in the dust? No? You need me to wait? Okay, we waited long enough now? All right. So over the course of today and I guess Friday, because tomorrow we're going to do the chalk line. All right. So today we're going to start orbital notations, and we should get to electron configurations. And then on Friday, we're going to learn how to draw dot diagrams and shorthand configurations. We're going to talk about, remember, what would it have been? What's today? Tuesday. Probably Friday. We talked about line spectrums, and we talked about why all those different line spectrums were different, right? And we said all elements had different line spectrums because they had different numbers of what? And different locations, okay? And because the electrons were in different locations, they had different line spectrums. Well, over the course of today and Friday, we want to talk about where these electrons are located. Currently, everybody in here can find the number of electrons, or at least I'd like to believe today y'all all remember how to find the numbers of electrons. If you've forgotten, we're going to review that, and everybody's going to pretend we know how. And if you've forgotten, we're just going to review it, and nobody's going to tell me they have forgotten. Okay? And then we're going to learn how to place the electrons in various types of drawings. Now, I warn you, the orbital notation is the longest. All right? But the other shorter types that you're going to moan about on Friday and go, I just showed us this the first time this fall, wouldn't make any sense if we didn't learn how to do the longest today. All right? So no whining on Friday. Now, orbital notations. In order to be able to draw orbital notations, we need to talk about the rules that go with orbital notations, and there are 3 of them. All right, so before we can talk about orbital notations, first of all, these are just pictures. Yep, to represent where electrons are found in an atom. Okay, that's what we're going to learn how to draw today. All right, pictures to represent where electrons are found in an atom. Now, in order to draw these pictures, though, there are 3 rules that we have to follow. And they have names that go with them. I will tell you now, for the purposes of your exam, you do not have to know the names for the final exam. Notice I specified for the final exam, you don't have to know the name. What am I telling you? There you go. You have to know it for my test. Okay? Y'all are in an honors class. I'm not asking too much. All right? The first one is called the Aufbau principle.
Because I won't.
Yeah.
You get A.
That's supposed to be that doesn't look like a word.
Aufbau is the man's last name. I have good news for you on the next test. You know how I've been grading all these free response tests?
Yes, I know.
I'm not crazy. No, I'm taking leave of my senses.
What'd she say?
She gets to use her notes. I said, no. You know, I'm tired. So I'm going to be nice to y'all.
Take it out.
It's multiple choice on this next test.
I'm still not gonna know this.
I do be better if I use words.
But the downside to the multiple choice answers is the 3 rules we're going to learn, the 3 answers all have the same names in them. Aufbau, Hund, and Pauli. So it's not like I made up other wrong answers to go in the multiple choice. But the answers are all there for you. You just have to pick it out. So if you don't know how to spell it, it's not a problem because the answers are there for you.
I'd rather do free response. At least you know what I'm trying to say.
Well, that's probably true. All right. So what does Aufbau say? He says that electrons will fill. Oh, and there's 65 questions on the test. Electrons will fill
Oh, no, we can go back to this.
the lowest. It's usually a pretty high scoring test. I think y'all will do well.
It's a what?
A pretty high scoring test. It's usually one of the highest scoring tests we have. No, high scoring. It's usually pretty good. What? Sometime next week,
Oh.
mid to late week. Electrons will fill the lowest energy levels possible. Okay? Electrons will fill the lowest energy levels possible. Now, I want you to think about this as motels, okay? Y'all have all been to whatever, whether you've seen it or stayed in it, motels. Maybe a 3-story motel. You go to the motel and you want a room. You have to fill the first level of the motel before you can get a room on the second floor. If there are any rooms available on the first floor, according to Aufbau, you can't have a room on the second floor. If there are any rooms on the second floor empty, you can't have a room where? On the third floor. You got to fill all the rooms on the first floor. Then you got to fill all the rooms on the second floor before you can go to the third floor. Okay? That's what Aufbau is saying. All right. Rule number 2. It's called Hund's rule. Okay? Electrons will fill orbitals of equal energy. And that has a special name. Those are called degenerate. Okay? Electrons will fill orbitals of equal energy. Singularly before or they pair up. Sort of like you guys who have siblings. Do you guys prefer to share a bedroom with your siblings, or do you prefer your own room? Electrons prefer their own room also. Now, sometimes, unfortunately, your parents had too many children. And what has to happen? You got to share a room. Huh? And sometimes atoms have too many electrons and they have to share hotel rooms or orbitals. Okay? Huh?
All I can imagine is like the example that you put that like strangers share. That's gross and weird. No.
Think of it as a field trip and you had to share with some kid in your class.
Okay,
I'm not asking you to share with a stranger. Okay? And the last one, the Pauli exclusion principle. Okay? No two elements have the same set of 4 quantum numbers, which basically means they all have different orbital notations. All right? So currently, we're going to look because I always forget. I think it's 118. Yeah, 118. There are 118 elements on the periodic table. So if I wanted to for homework tonight, how many different orbital notations could I make y'all draw tonight? 118. I would never do that. It would be stupid. Okay? It's sort of like making y'all memorize the periodic table. I know teachers who do that. It's stupid. Okay? There are three of them if you count that tiny one hanging in the room, and I gave you one. It's stupid to memorize the periodic table.
Especially when you get one.
Exactly. You get one on the final. Okay? I know teachers who don't even give the blue chart out to their students during the course of the year. I agree.
They get on the same every
They're teaching you.
All right, everybody caught up? All right, we need one more thing in order to be able to do an orbital notation. Now, you can use this chart anytime you want to. There's a catch, though. I know there's always a catch in there. You have to be able to draw the charts. Okay? I'm going to teach you how to draw the chart, but you have to be able to draw. Okay? Now, before Antoinette asks me, can you use your notes again? No. Okay? You can't. Now, this is a chart of orbital overlap. Essentially, and don't draw this crap that I'm getting ready to draw here. You can write the title, but don't draw this, okay? Essentially, you have a 1s little tiny sphere, okay? And then in the second energy level, you have a bigger sphere, okay? A little bigger sphere on top of it. And then you got your P sublevel. Okay? And then you got your third energy level on top of it. Okay? And then add in your P sublevel. And then you got your 3D that I can't draw. And you got 5 of them on top of it. And eventually, these things begin to get overlapped on top of each other. Now, imagine what this would look like if I could actually draw, and you have all these things laying on top of each other. eventually they get out of order, okay? Now, because these things get out of order, we have to know the order to be able to draw what the electrons are in a picture. Now, we're not memorizing this, okay? I don't want anybody to memorize, so we're going to read a chart. So, how does the chart look? All right, can you count 1 to 7?
Maybe.
Okay, you can count 1 to 7, straight down. Now, this works really well on lined notebook paper. So, what's the first sublevel? So, I'm going to put S beside all of 1 through 7. Did I lose anybody yet?
Yeah.
I wrote 1 through 7. And what's the first sublevel? Okay. The second row starts at 2. What's the second sublevel? So I'm going to put P there. All right. The next row is going to start at what? What's the third sublevel? We're not going to have a row. And the last row starts at what? What number? All right. And what letter?
I almost did. Oh, you're right. 4.
So, the first row is 1 through what? 7, and what letter? The second row is 2 through 7, and what letter? The third row is 3 through 7, and what letter? And the fourth row is 4 through 7, and what letter? Can you remember that?
Yes.
Okay, because I got to do the hard part, yeah.
Oh.
That's the easy part.
I messed up on writing numbers.
Dang. All right, now I can't fix that. Go back and fix that now.
No,
Because we got to do the hard part, yeah. All right, the chart is read diagonally.
Of course.
So, we have to draw in diagonal arrows.
Yeah, I'm confused about that.
Wait, he goes through the.
Pretty color.
So 5S is not included in anything?
I see. What?
That's why I told you that it works really well with lined notebook paper.
Oh, very.
Wait, okay.
5S is supposed to be on that line. Here, I can move him up a little bit. Let me get my black back. There.
Okay.
So, those green lines are hold over that.
There.
Okay,
Two
so,
estimates online.
so what I'm
Yes.
assuming is this, it's supposed to be like 1, 2, and then like the 30.
Yes, we're going to practice reading it in a second. Yes.
Wait, 3P and 4S are on a line, right?
Yes, they're on the same line. Do I need to move 4S?
And
That's why I said this works really well on lined paper, and I don't have lined paper.
3D, 4P, and 5S.
I still messed up. Did you do it?
I did okay. I said okay, not.
There. Is that better?
Sure.
Now, make sure it's correct. You have the arrows exactly like they are on the board. Because if they're wrong and you're duplicating it wrong, you're going to be in deep doo-doo.
Right.
Some extra there. Yeah.
We can look at it.
I'm not looking at 21 charts
I
in
got you
here.
set for a small.
But I will check the dude who numbered it wrong.
Yeah.
Oh, no, yeah, because you need that.
Yeah, we'll try.
Okay, so Chris.
All right, does everybody have it?
No. Okay.
Now, I do recommend, before we take a quiz on this, at least practice drawing it once or twice before you get to the quiz and you draw it wrong. Because if you draw it wrong, all of your answers are what? Wrong. There, listen to me. There is no partial credit on these. You either do them right or you don't. Okay? If you count wrong, it's wrong. I can't fix that you were supposed to draw 18 electrons and you drew 17 electrons. Okay? You got to draw them and count them right. Yes, ma'am.
So you said it's easier to do on line paper. Would we be able to do it on notebook paper?
Yes, you can pull out a sheet of notebook paper and draw the chart so that you have lined paper. It's just easier to space things on lined paper than it is on clearly on the board. Okay, and I've done this a long time and I still am off sometimes. Now, everybody got their chart drawn. All right, let's talk about orbital notation. Let's say we start easy. Nitrogen. How many electrons does nitrogen have?
Wait, how'd you know that? Oh.
Remember when we said we were going to pretend everybody knew? Nobody's going to ask me how we knew that. So look up nitrogen on your periodic table. Okay? So when we look up nitrogen, what number tells us the number of electrons again for anybody who might have forgotten? The atomic number. Okay? So we look up nitrogen. All right?
Are we making you proud right now?
Yes, you are. Particularly the people who didn't say, how do we know that? All right. So the atomic number is what? 7. So the atomic number is 7. So there are 7 electrons. Does everybody remember that now? It's coming back into focus, right? Okay.
You can say that.
Okay, it's coming into focus. So there are 7 electrons because there are 7 protons. 7 protons means there's 7 electrons, right?
Yeah.
The atomic number 7, the little number is the atomic number, right? Okay, so everybody remembers that now.
Yeah.
If you don't, ask a neighbor. Don't say, I don't remember that out loud again. So, when we look at nitrogen, we have 7 electrons. So, if we look at reading our chart, okay, this is the order the electrons fill in the energy levels. Now, when we read the chart, the first thing we see is 1s, right?
Yeah.
When we get to the bottom of the arrow, where do we go?
Do it.
Top of the next arrow and down, and we see what?
Do it.
Top of the next arrow and down, and we see what? To what? Oops, get off there. But to the next arrow, we have what? 3p, and then what? Now, when we come down and we see 4s, what do we see at the top of the next arrow? 3d. So we see a 4s before we see a what? There's overlap right there. So who's smaller, 4s or 3d? 4s is actually smaller than 3d. 3d is bigger in an atom than a 4s is. So 3d, and then we have what? 4p, and then we have what? 4d, 5p, 6s.
Is bigger than 5s.
Yep, you got overlap. 5p, 6s, and then what? 4f, 5d, 6p, 7s. Everybody see how we're reading it? I am not going across. I'm reading down the arrows. Are you okay with that? All right. So the first thing we read in the chart is what? We write 1s. What's the next thing I see in the chart? 2s. All right, we're going to stop there for a moment. Now, what does this stuff mean I just wrote down? This is my energy level that we just talked about. This is my sublevel we just talked about. Now, the next thing we're going to draw is the magnetic quantum number, or the orbitals. How many orbitals does the S sublevel have? 1. So we're drawing one line above S. Okay? This right here is my orbitals. So I draw one line. 2s. How many orbitals does S have?
1.
So I draw one line above it. It doesn't matter that it only has a 2 in front of it. It's still an S. It only gets one line. Now, let me ask you this. How many electrons can I put in an S sublevel? So I can put 2 here, and I can put 2 there. So that's how many so far? 2 plus 2 is, how many do I need to place?
7.
So I only have enough space for 4. Am I good to go?
No.
So back to my chart I go. What comes after 2s? 2p. So I'm going to put 2p right here. All right, now, that's my energy level. That's my sublevel. I need my orbitals. How many orbitals does P have?
3.
So I'm going to draw how many lines?
3.
1, 2, 3 lines. Okay, those are my orbitals. Okay, these lines right here are my orbitals. Now, these are the ones that I said in Hund's rule are equal energy. That's that new word I gave you. I spelled it wrong. Yeah, only I didn't spell it right. Let me go back and fix that mess. Degenerate. There, I spelled it right. They're degenerate. Okay? Now, how many electrons go in each orbital? How many spaces do I have now?
5.
So 5 times 2 is how many?
10.
So do I have enough space for 7 electrons if I got 10? Yeah, I don't need to build any more spaces. No, it does not have to be exactly 7. It cannot be under 7. It can be more than. Huh? Yep, that's what we're getting ready to do. All right, so now to answer Caroline's question, we got to put the electrons on the lines. Okay? So the first electron, according to Hund, has to go in which floor of the hotel? The bottom one. So 1s is the bottom floor. So the electron goes on the bottom floor. Is the first floor full?
No.
So guess what has to happen?
Fill it.
They got to share. Now, what did we learn about the spin quantum number? It's positive or negative 1/2 because they spin how? Clockwise or counterclockwise. So if that one's spinning up, the other one has to spin how? So the second one's going to spin down. It's got to share. So sorry. Got to share your room. It's not full.
But where did
Where what?
I don't get where the arrows came from. I thought we
The arrows are representing the electrons. That's the representation for the electrons.
You said
All right. This is the electron. The arrow is the actual electron. Okay? We don't write E, we draw arrows. Okay? So, where's the third electron going? Okay? Where's the fourth electron going? Because it's not what? How do I draw him? Okay. So we've drawn 4 of our 7. Is everybody okay with the first 4?
How do you know that it's not? Why do you say it's not full?
Because how many electrons can go in an orbital?
Oh,
2, right? That's how you know it's not full. All right, so we're at 4 electrons. We have 3 to go. All right, so electron number 5 goes in 2p. All right, he took a room. Now electron number 6 comes along, and he looks at number 5 and he goes, I can share with you. Are there 2 more vacant rooms? What's he going to do? That's exactly right. Think about it. You've got a new house. You have a brother and a sister, or a brother or a sister. You know what you have at home. Do you want your own room or do you want to share? Most of y'all probably want your own room. I've met some kids who want to share, but most of them do what? Most of them want their own room. Electrons are the same way. They say, thank you, I'll take my own room. You don't what?
Why are we not putting 2?
Yeah, because
Okay. Do you have a brother or a sister?
I have 2.
You have 2. Okay. Do you share your room?
No.
Okay.
2.
All right. The electrons are you. Do you want to share? They do not want to share either. These orbitals are your bedrooms at home. They're equal energy. Okay? So
Why does 2P get the option?
because their orbitals are all in the same sublevel. Okay? This sublevel is at 2s. It's not in the same sublevel. It has to be full before it can move on. These are all in the same sublevel. They're all 2p. Okay? That's why I'm trying to tell you they're of equal energy. They're degenerate. They're all 2p sublevels. Okay? Now, they can choose to share or not share. They're never going to choose to share when they're all in the 2p sublevel. Okay? Sort of like you have a 3-bedroom house. Mom and dad have a room. You and your brother or sister have to choose between sharing and having an empty bedroom for a playroom, an office, or whatever, or each of you having your own bedroom. Most kids are not going to choose to share. The sublevel is the rooms. Okay? So number 7 comes along, and it can either share with these 2 or it can take its own room. It's going to take its own room. So they're all going to have their own rooms. Now, to illustrate the difference. Now, let's say that we take oxygen. And I drew nitrogen right back up here. All right, and I'm putting oxygen. It has 8 electrons. And I'll let you catch up with what I just drew here. All right. All right, oxygen has 8 electrons. So the question becomes, what happens with that 8th electron? Does it have to share? Or can I add another sublevel and put in like 3s because it doesn't want to share? Does it have to share? Or can I put in a 3s?
No.
That's what I'm asking. Based on the rules, what do we have to do? Why can I put in 3s? Okay, it's 2p full. So can I put in a 3s if 2p is not full?
No.
No. Okay? It's like this. All right? Everybody has their own room in the house. And guess what? Oops! Mom and Dad got pregnant again. And there's no money for an addition. So guess what happens? Maybe they adopted. They foster parented. Doesn't matter. There's another baby in the house.
kill it.
Killing is not an option. Word about you. You need to lay off the black and stop doing whatever you're doing. Okay? Woo! Okay? There's no killing it. No adoption. It's staying. It has to go in the house. College is coming, yes. Okay? So, it's always possible too. I'm worried about you people. All right? Don't worry, you'd have to check me into the funny farm. All right?
We did not add that on the first one.
My point is, if you have oxygen, which has just 1 more electron, okay, can you add in 3s for that extra electron, or does it have to go in 2p? At this point, it doesn't have an option. It cannot go here. Cannot add another sublevel because 2p is not what? It's not full. I am sincerely sorry that 2p is not full. Somebody has to do what at this point? It has to share.
So for 2P to be full, each one has to have 2.
Each one has to have 2.
Right.
So it would go back and start sharing at that point.
And
Yes.
if it wasn't enough, like if they didn't have to have 2, like the first one, you just put.
You just put 1.
So,
So say there's 11.
yeah.
So if there's 11, this one gets 1. All right, so let me have another board here. Get a little small at the
Do
bottom.
you always just start with like 1s?
Yep.
2s, or 2p?
Because they're the first things in the chart. So let's say we have sodium. All right, sodium has 11. So you'd have 1, and I'm drawing half arrows, 2, 3, 4, 5, 6, 7. Now when you get to 7, this one gets number 8, number 9, number 10. Now that's full. So once you have filled 2p, then you go to the next thing in the chart, which is 3s. So you put 3s there, and you said 11, so that's 10. So number 11 would go there. Okay? Diamond.
Okay. So each arrow, like each individual arrow, is 1 electron.
Is 1 electron. Correct.
Okay. That makes more sense, I
Okay?
guess.
Denasia.
I know we need the blank ones, like for 2p now. Like you didn't put that for 3s.
I didn't what?
The blank ones that doesn't have a number underneath it.
Because it has 3.
I only put the 3s there because,
No, I know why you put just.
Because the blanks are 2p. Because
oh,
S only has 1 orbital.
yes. Yes, the blank lines come from like an S sublevel has 1 line because it has 1 orbital. P has 3 lines because it has 3 orbitals. D would have 5 and F would have 7. Is that what you're asking me? Or are you asking me how far I know to go?
That's what
How far?
No.
This? Okay, that. Because it's based on the orbitals that we learn, the shapes, you know, with the X, Y, and Z axes. That.
So why would it be 1s and then 2s?
Because it's the order we're reading the chart. So 1s is first, and then down this arrow would give us 2s next. Okay, and after 2s, the next thing we would get is what? 2p, and then next would be 3s. So we're reading it in that order in the chart. Okay? All right, what else?
So this is like talking about the location of the electron.
Yes, this is the order they appear in an atom. Yes. Why wouldn't I give you homework on this?
Because we don't understand. Just let us.
You can draw off some orbital
You
notation.
give us homework tomorrow, and we can have time.
Tomorrow you're doing a lab report.
On this, a lab report.
All right, we're going to do iron. Find iron. How many electrons? Tomorrow's homework's a lab report. All right, so 26 electrons. All right. So, tell me the first thing in your chart. You got your chart in front of you, right? Well, you need to be able to see your chart. Okay? What's the first thing you see in your chart? I can do it in my head, but I don't have it in front of us. All right, so 1s. Okay? So how many lines do we draw above an S? So I draw 1 line. All right, well, 26 electrons fit on that 1 line.
Yeah.
Back to your chart. What's next? So how many lines above 2s?
1.
All right, back to your chart. How many lines do we put above a P?
3.
All right, Denasia, you with me on how we got the lines? Okay, so if I count, how many electrons can I put here? 2, 4, 6, 8, 10. That's not 26. Back to our chart. What comes after 2P? So I put 3S. How many lines go above an S?
1.
Okay, next.
Wait, so does the numbers in front of the letters mean anything?
Do the what?
Numbers in front of the letters mean anything?
In terms of the lines?
Yeah.
Nothing. Okay, what comes after 3S?
3P.
All right, how many lines go above a P?
1, 2, 3.
Okay, so 3. All right, let's count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. We're getting closer, but we're not there yet. Okay, what comes after 3P? How many lines above a 4S? All right, after 4S.
3D.
All right, how many lines above a D? All right, I heard 5. All right, so if we count this time, that was 18. So 20, 22, 24, 26, 28, 30. 30 will get us. All right. Is everybody okay with the order we got and how to draw the lines? Yes or no?
Yes.
Anybody not okay with the order or the lines that need us to go back? And today? You okay with the order and the lines? Okay. You're the one telling me not to give homework because you don't understand. I'm trying to make sure you're with me.
I just don't want to do it.
Oh, shut up with that now. All right. So if I put in my arrows, the first one goes where? All right. So 1 up. And then what?
1 down.
1 down because it's got to be full. All right. The next one. 1 up. 1 down because it's got to be full. Now in 2P. 2P has how many lines? 3. So it's a 3-bedroom house. So the electrons are going to do what?
Share.
They're not going to share at first. They're going to do what? They're going to separate and take their own rooms. So everybody gets their own room.
Can I jump ahead with that? Well, never mind.
What's wrong?
I was gonna ask you, so everyone you get 2 except for the last 2 on 3D.
For iron? No.
So, wait, so why would you just not go ahead and write in the other 2?
You can. If you realize that this is the one that they're not going to be full on, you can. Okay? But the problem is, here's what happens. If people go through and they start 2 2 2s, they get here and they do 2 2 2s.
No, I did 2 on the first. I did 2 on the first 3, and the last 2 it was just 1. Like, you know what I'm saying?
You didn't count right.
Through?
Yep.
Wait, so can you not do 2 and go throughout the entire thing and then go back and
No. You can't.
You didn't.
All right? So 1, 1, 1, and then they share. 1, 1, 1. Now, if you want to do 2 2 2, I don't care. As long as you don't mess up the 3D. 1 and 1. Now, we're at 20 right there. That's 20 electrons.
Oh,
I have 6. Okay? So 1, 2, 3, 4, 5, 6.
Boom, okay.
Okay? So if you have anything other than this on your paper, when I grade it, it's what? It's wrong. There is no partial credit. So when Almaja said to me, if I had this, it's wrong. Okay? And most likely, she just counted wrong. She had the right concept. She counted the electrons wrong. It would have been incorrect. How is what right? So you have 20 this right here is 20 electrons. So we need 6 more. So everybody gets 1. So we're at 25. So after everybody gets their own room, number 26 has to do what? 26 has to share. Because 26 can't go to the next sub-level, so he has to share. You can if there's not enough. Like, let's say you were doing something like 22. If you did like titanium, which had 22, you'd have 3D, 1, 2, 3, 4, 5, and you were only drawing 22 electrons. You'd draw 21, 22, and you'd stop. You wouldn't fill in those other 3.
But all of them have to be full before you can double them.
Yes, you'd have to have a single on all of them before you can double them. Yes, that is correct. You put 1 on all of them before you double them. Yes.
Okay, so question. When we get to the ones that have the option of them, do you single them and then still, okay, so the way you did it was
you did 2P singles in first, and then you went back and you made them sure. Is that how you're supposed to do it, or can you do the 2P single and then go into the 3 and?
No, you want to go ahead and double them before you go there. Double them before you go here.
Why?
Okay? Why? Because if you don't, you're likely to miscount. Okay? Now, I don't care if you do 2, 2, and 2. If you're one of those people who looks at it and goes, okay, I know these are the only ones that are going to have singles, and you want to do 2, 2, 2, 2, 2, 2, 2, 2, and then you know these are the singles, that's fine, as long as you visualize that way. I don't have a problem with that. But don't start 2, 2, 2, 2 and wind up with blank lines over here, okay? Because you'll wind up in trouble. All right, so homework. Even though Antoinette doesn't want any. Your homework is to draw orbital notations.
That's what we just did, right?
Yes.
So we pick any ones.
No, I'm going to assign them. All right, let's do aluminum.
That's what I'm gonna do.
Let's do selenium. Let's do molybdenum, or molybdenum as everybody calls it.
Only give us
And let's do lead. I was only going to give you 4. You want 5?
You're so gracious.
I was thinking 4, but I'll give you 5. I mean, I don't mind.
We do.
I have other classes.
I think I'm very light in homework.
Yes, thank you. Okay.
I'm so glad to.
But it's only 2, they say 2. But you know how you like it.
I mean, I get
Yeah.
All right, if you guys have a calculator, put it up. It looks like I'm missing 1.
It's